Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to continue our lessons on negative exponents. We're going to do a little problem here where you should come to a very good understanding about what negative exponents do. Okay, so I recently purchased a new plant. When I bought the plant, it was exactly 1 foot tall. I noticed the plant was growing at a pretty fast rate, so after 1 month I decided to measure its height. After 1 month, my plant was 2 feet tall. After I decided that I would measure the height at the end of each month. As I give you the measurements, please fill in the data in the table below. So let's fill this in first. When the plant was bought, it was 1 foot tall, so let's put a 1 here. And then after 1 month, it was 2 feet tall. Okay, now you need to fill these in as I read. After 2 months, it was 4 feet tall. After 3 months, it was 8 feet tall. And then we had to move the plant out of the house because it was getting too tall. We relocated it to a nearby office building. After 4 months, it was 16 feet tall. And after 5 months, it was 32 feet tall. We want to figure out what the pattern is here. Go ahead and fill in the last two columns once you figure that out. And then predict what it will be after 8 months. Okay, and we're going to add on to the table and put that in there. So go ahead and do that. All right, so think about how you got those answers. I'm hoping that you guys have noticed that this is a ×2 pattern each month. So one thing we could do on our calculator is we could just keep multiplying by 2 to get the next answer. So here's how you do that on your calculator. Put 1 in, which is how tall the plant was at 0 months originally, and then press enter and then ×2, and then enter for every month after that. So that's 2 months, 3, 4, 5, 6, 7, 8. That would be one way to do it. But since we are just multiplying 1 times 2 times 2 times 2, etc., we could just use a power to represent all these. So we could just do 2 to the 8th power to get that 256. So if we use a variable to represent each of these, we could say that y is equal to 2 to the x. All right? And that's your answer here. Okay, so x is the number of months and y is the height of the plant. So if you wanted it to be more, represent the problem a little better, we could use h for the output and then use like m for the input power. All right, so recently I went back to the store where I bought my plant, and I found that the plant was alive a long time before I bought it, and that the store owner believes it was growing at the same rate even before it was 1 foot tall. Assuming this is the case, that my plant was doubling in height each month, how tall was the plant 1 month before I purchased it? Okay, so go ahead and see if you can figure that out. Okay, so that would be the -1 month if I'm going backwards. And going backwards, you should be thinking, well, then I have to divide by 2. So if you do 1 divided by 2, you get 0.5 feet tall, right? Because 0.5 is doubled and that equals 1. All right? And so what we just figured out here is this, that 2 to the -1st power, if we use this equation, is equal to 1/2. And I like to write negative powers as fractions. I think they're more meaningful that way. How tall was my plant 2 and 3 months before? Let's call that -2 months and -3 months. So go ahead and figure those two out. All right, so here's what I was thinking. At -1 month, we were at 1/2 foot tall. And if I go back to -2 months, that I would have to divide that by 2, so I would get 1/4. And then at negative 3 months, I would have to divide that 1/4 by 2, so I would get 1/8 of a foot tall. Okay, you should have noticed that your equation in problem 3, the exponent represents the number of months. And we just talked about this, that 1 month before would be negative 1 month. 2 months before would be negative 2 months. And 3 months before would be negative 3 months. That makes sense. So we're going to fill in this table with the information we have, and you can continue it. So negative 1 month, we were at 1/2 foot tall, 1/4, 1/8. Go ahead and do the negative 4. We already have these values. All right, for negative 4, you should have said, oh, that's going to be 1/2 of 1/8, which is 1/16 of a foot tall. Based on questions 4 through 7, what's happening when we take a positive number and raise it to a negative power? Go ahead and think about that for a second and respond. Personally, I like to think about it as dividing by the base. So if I do, like, say, 2 to the negative 4th power, what I'm doing is I'm dividing my 1, which is the 0 power, by 2 4 times. Okay? And so it just keeps getting smaller when you're dividing by a base that's greater than 1. Okay? And the patterns you should notice is that 2 to the 4th is the denominator of 2 to the negative 4th, and all the negative powers have 1 as the numerator. So we can describe it this way: 2 to the n, let's say 2 to the negative n is equal to 1 over 2 to the n, because we're just dividing 1 by that base n times. All right, so go ahead and fill in these. Actually, let's fill in, we have the 6 and the 7 already, don't we? 2 to the 6th power was 64. 2 to the 7th power was 128. Based on that, go ahead and do these two. All right, you should have been thinking that it's just 1 over those same things, because we are just taking 1 and dividing it by that base of 2 6 times. So it's 1 over 2 to the 6, and 2 to the 6th is 64, so it's 1 over 64. All right. So thinking about that, and you're just going to have use your sense about this at this point. Determine which of these numbers is greater. So circle the one you think is greater. Make sure you're thinking in terms of exponents, that exponents are multiplying by that base. Or in the case of negative exponents, you're dividing by that base. So just give it a guess, and I'll show you my answers. All right, I wonder how many people got 100% there. So here's my thinking. So the base is 2. When you do 2 to the 400th power, that's multiplying by 2, 200 factors of 4. Well, that'll definitely be bigger than 300, multiplying by 2 300 times, right? And when you're dividing, the more you divide by that base, which is what we're doing here, we're dividing by 2, the more you divide, the smaller it gets. It keeps getting broken up into smaller and smaller pieces, so the less you divide, the bigger it is. This is exactly the same as the one we just did, because of what we found out, that 2 to the negative 300 is actually 1 over 2, 1 divided by 2 300 times. Okay, now these two numbers are the negative versions of these two numbers. Okay, and we know that the bigger the negative, and I don't like how I'm saying this, but this number is greater, right? As negative numbers, the bigger it is, the smaller you're getting. So so this number will be further right on the number line. All right, I'm going to give you the example, and then you're just going to do it on your calculator and figure out whether it's positive or negative. So I'll help you with the example. So we want n to be an odd integer, and we want the base to be a negative number. So let's just do negative 2 to the 5th. Just make sure that that power is an odd number. Now, what I'm wondering is that positive or is that negative? Okay, so just do it on your calculator to see. And on the second one, we're going to do where n is a positive, or is an even integer. So like maybe negative 2 to the 6th. And maybe you should try a couple of these. So just to make sure, verify that you're seeing the right thing, you might change this here to another odd integer like 11. Maybe try another even one just to make sure that you know whether it's positive or negative. And then this last one, do any positive integer to your power. This will always be either positive or negative, and you'll figure that out when you put it in your calculator. Okay, the one thing here, you may be thinking, well, what if I did an even integer on this one? Well, go ahead and try it. You'll notice it's still negative. And that's because these are just negative numbers. That's what the negative out front is telling you. Just like this is a positive number, and so is this. Negative 2 to the 7 is just the opposite of 2 to the 7th. So one is positive and one is negative. Okay. You may have to go as you're doing problems, just do a quick little example on your calculator. All right, let's do this again. Circle the one you think is greater, and then we'll talk about your answers. Sometimes I really have to think about these also, but which is going to be more, this is the way I'm thinking about this, multiplying by 3 18 times or multiplying by 3 20 times? Well, multiplying by 3 20 times is going to be 3 factors of 2 times bigger. Or I said that wrong, 2 factors of 3 times bigger, so 9 times bigger than 3 to the 18th. This is a positive number because it's a negative base, in parentheses, to an even power. And this one's a negative because it's a negative base to an odd power. So that would probably be the trickiest one. You don't have to use 8 and 9, though. If 8 and 19, you could just do 8 and 9 and you'd get the same results. You'd find that this one is negative. So if your calculator is giving you weird answers, if you're trying to use your calculator to check these, don't be afraid to change the powers. Just keep it so this is even and this is odd. Okay. And on this one, these are both negative numbers. And the larger the negative number, or the more negative it is, the smaller it is. So this one is less negative because you're only multiplying by 3 500 times, not 800 times. By the way, those are astronomically big numbers. You probably, on your calculator, you won't even get it to show you the actual number. It's so big. All right, let's do one more of those. Which of these do you think is greater? And the fraction base makes a big difference here. Let me help you think about that, and maybe you can change your answer. So let's just say I have, first of all, let's talk about this. The fact that you have a negative base, negative 1/3, and an even power means this one's going to be positive. This one also has an even power, so it's going to be positive. So they're both positive numbers. So let's just do a fraction example. Now, what happens as you multiply by fractions to the answer? Does it get bigger or does it get smaller? Well, 1/2 times 1/2 is 1/4, times 1/2 is 1/8. Basically, you're splitting it in half each time, so the more you multiply by a fraction, a number between 0 and 1, the smaller it gets. So keep that in mind as you make your choice. You should have said that you want to multiply by the base negative 1/3 less times, and it'll be greater because of the fraction. When you're multiplying by a fraction, the more you multiply by that number, the smaller it gets. All right, we're going to do some sorting here. I'm just going to tell you right now, I'll help you with the first two. Some of these equal 9, some of these equal 1/9. So we're going to sort them into two groups. All the ones that equal 9 put in this circle, all that equal 1/9 put in this one. if you weren't sure on that, you could use your calculator just to make sure, check your answers. But the only one that equals 9 is 3 to the second power. I could make one other number using these. If I did 1/3 to the negative second, if that was one of your choices, that would actually equal 9 because remember you flip them when you have negative powers, and now it's positive second, and so that's 9/1, which is just 9. So we could add that to the list, and I think that's what we're supposed to do. So, all right. Oh yeah. Okay, let's sort again here. All of these are either 9/4 or 4/9. Find all the ones that are 9/4, put it in the first circle. All the ones that are 4/9, put it in the second. All right, here's what I got. Hope yours agrees with that. Again, if you need to use your calculator for a while until you get comfortable with these negative powers and what they do, please do that. All right, we're up to the homework now, so you should be able to do that. We already did the 13 through 18 part of this, so you're just going to do the other parts. Good luck with that, and we'll talk to you soon.